kerana menjemput saya jugalah untuk memberi talk tentang ni. Maaf kalau saya cakap BM ni agak kaku sikit sebab saya normally talk in English in a very in a professional talk, so saya akan continue dalam English. So if you have any question, you can ask me or you can talk in both BM or English. Should be no problem for me to answer. So let me give you a bit of my background. Okay, I've been working in Schneider Electric for the past 7 years, if I'm not mistaken. My core of expertise mainly on the technical portion. Design, I'm not fully design, but I support the design for the consultant and also for the contractor and for the developer in selecting the best breaker application to ensure that they will have the optimum safety in the design and application of the electrical networks. So let me share you my screen. Oh, cancel. Share. So can you see my screen?
Yes, yes.
Yes, yes.
Okay. So today talk is about the technical sharing on the final distribution, protection, and e-mobility. So what I'm saying is that here we have two course title today is a final distribution, protection, and e-mobility. What did I stress about final distribution protection is mainly on the commercial and residential. When I mean by commercial is school, hospital, commercial area, shop lots, and also residential, which part of I'm not sure either you have been taught about this in university. But during my time, I have never been teach about this. So this is a great opportunity for me to share with you. So when you go to the market after you graduated, you will be ready and more equipped with the knowledge. So you'll be more what we call that graduate yang complete lah dengan semua informasi yang diperlukan dengan trend semasa, especially nowadays. We are going for Industry 4.0, which is more on automation and cloud computing. Okay. So, okay, a little bit of background. All right, I will go directly to the title, and maybe in the end, if you guys want to ask me about my experience, what I've been doing for the past 10 years, we can go into that portion. So we finish first with the presentation first. So first title we got of a circuit protective device. So if you see the by definitions is a device used to protect cables, people, livestock against electric shocks and fire resulting from overload and fault current. So this is the main core of the circuit protective device. It also applies to MCCB, ACB, air circuit breaker, or vacuum circuit breaker, which you see in a higher at the utilities part, at the transmission part or generation parts. Okay. So in a nutshell, for electrical transmission in Malaysia, you can see power generated by power plants goes to the substation and then go to the national grid, which will be transmitted for long and short transmissions. And then it will goes to a substations where it will be divided to directly to a large power consumers, mainly for factories. All right. Or it will go to another substation where it will be divided to two core, which is I call it hospitals, schools, small industries, commercial center, or residential area, workplace, and shops. So our discussion topics today will be focusing on these two. Why? Because these two have less competent person to handle. Okay, when I say non-competent person, a simple term like your husband, your wife, your son, your kid, your father, your mother, your grandfather, who doesn't know anything about electricity, okay, who take for granted, or not just for this group of people, also for most of engineers, consultants also take for granted for electrical safety and protection. So please open your mic. Have you seen this before in your entire life?
Yes, we do.
Where
Yes.
is it located?
Do.
DD box.
Why
At my house, Rata. At
In the
Bangkai.
house.
in the house? Location? In the house is a very big term, in location.
DD box.
Location?
Store.
At the wall front of you.
In your house now, where is it located?
Store. Store.
Yes. So if
At higher place.
so normally you will see this box, doesn't care it's a metal, okay, or in the left side is a plastic. Is this is a PVC or plastic or fire retardant enclosure box. This one we call it metal box. So you can see this both in residential is very simple. You can see it in the front door, the entrance, or in the storeroom. Or if you are living in the double story, 3-story house nowadays, each of this story we have one. Okay, so what is function? The function of this thing. Oh, one question. In this 1 year, everyone have ever opened this thing before?
Yes.
Yes.
Open it. Why did you open?
Yes. Trip. Trip.
House
House
trip.
trip.
Okay. So if there is no power trip, did you bother to open this thing or take note of whatever happened in this thing?
No. No.
No.
Yeah, this is a common answer.
Dangerous.
And then did you guys take note on this portion or this portion whereby they have a test button? So have you guys even tried to push this thing even one time per year?
Yeah.
Yeah.
When,
Oh,
yeah.
Push monthly.
Very strict.
no, not because of trip. And I mentioned is that this thing, right? This thing they have a white here or there's a black color here with the T button. So when there's no tripping, did you guys even open and tested it to ensure it still function?
Yes. I push
Yes.
monthly.
Monthly.
Yes.
Wow. Based on the
Simple.
standards
Yeah.
requirement, you need to test it by quarterly or 2 times per year to ensure it still function. Okay, I will go in depth each of these component to give you more information. What is it? All right. So the final distribution connects and provide protections. Okay, protections with all the loads for your lightings, for your power, for your water heater, for your aircons or any of your load, maybe PS5, who don't know it's PS4, PS5, right? Okay, so this is a thing that provide protections every time you connect your electrical appliances. All right, but this thing is taken for granted every single day. Why? Because you are still alive. There's nothing happened to your house. There's nothing happened to your office. All right. So what is inside? Simple. You have a miniature circuit breaker. Okay. If you go to study, you will see at the substation or distribution from the TMB, you have ACB, right? Air circuit breaker, vacuum circuit breaker, whatever design of circuit breaker. So this is the miniature type of circuit breaker which provides you against overload and short circuit. You will have residual current device, protection against leakage current, or simple term electrocutions. Okay. Okay, and then you will have an SPD, protection against lightning strike and surge current. I will go to one by one of this. So a little bit of standards. Okay, so every products that we are selling, we must follow the IEC standards or the Malaysian standards. So you can see column international standard and Malaysian standard, the standard is almost the same. Only they put MSIEC. So this is where Malaysian standard come into play, whereby they need to review the standards and then adapt become MSIEC. But if you want to refer to IEC, is still acceptable. Okay, because the adaptation is mainly on the ambient temperature and Malaysia style of installation, which is different from different of country. But basically, the core component inside is the same. So for MCB, there is two standards, 60898 for domestic and unsupervised. As I mentioned, those who doesn't have technical or information or anything at all about electricity, and 947 for industry and supervised, whereby you will have a technician, you have a wireman, or you will have what we call it a chargeman or an engineer who can monitor and to ensure that protection is achievable 24 hours, 7 days a week, 365 days a year. All right. And then you will have RCCB and RCBO is a combination under RCD, as I mentioned. So 61008, 61009 for RCBO, and then your SBD 61643. Why I'm showing standards? Because when you go to the market, when you guys graduated and goes, you will see standards will come in play when you want to do anything in design, in finalization, everything we go referring to the standards. All right. So we go for first miniature circuit breaker. What is a MCB? It's a miniature circuit breaker, as I mentioned earlier. It's a breaker that open when there is an overload and short circuit, where its basic function to detect and to interrupt the current flow. In a nutshell, it provides safety. So two standard, as I mentioned before. So functional architecture, if you go and buy any breaker, or if you pandai now go and open one of the breaker in your house, but make sure the power is off. Okay, you will see each of the breaker we have the same design component, which is top terminal and bottom terminal for incoming and outgoing. Means the power goes in, goes out to the load. All right, you will have thermal strip for overload tripping. So we go in depth what is thermal strips. We will have a power contact for overcurrent braking, so for open and close. For arc-tube, for everything with electricity, when you force open, you will create an arc. Okay, it will not big as the vacuum circuit breaker or air circuit breaker, but the arc that being generated when you open and close the circuit must be extinguished at arc-tube. You will have a magnetic coil for short circuit tripping. Okay, and then other accessories for clip to secure on the distribution box, and then you will have a toggle to on and off switching. So this is any brand when you open up, not just Schneider. If you go for ABB, if you go for MaxGuard or local brand, you will have a same component inside. Only different is the performance. Okay, standards evolution. Okay, just go a bit. Okay, you will have IEC, adapt by MS, become MS IEC. Okay, and then why it's being adapted is one of the reason is under Suruhanjaya Tenaga or Energy Commission is being regulated. This kind of breaker must have a serial label to ensure that it's been tested and safe to be used by the end user. Okay. So how to apply the standards is simple. For residential building, NI8-1, only one standards. But if you go for commercial industry, you can apply both based on the design, based on the location itself. Why am I saying for commercial? Yes, you should have both. But for industry, let's say a factory, they should have an office factory. They should have a canteen. They should have what they call it, hostel. Some factory we have hostel. So 947 will not be applied there, but NI8 will be applied, but it was located in the same industry location. So this is where consultants have to play their role to ensure that they apply the correct standard to ensure that the safety is maintained towards the whole system of electrical networks. So the differences, okay, this is where people get confused, okay. Not just from student, I also get a lot of inquiries what's the difference between NI8 and 947. Okay, basically NI8 due to the rated current, okay, you can see for NI8 from 6 to 125 amps, 0.5 amp to 160, breaking capacity lower than 25, this is lower than 50, up to 3-phase, single phase and 3-phase. This one can varies based on the machine requirement. Impulse voltage for the protection, if there is an impulse. Pollution degree is more on the environmental profile. Curve BCD for 947 for industry, BCD, KZMA. So KZMA is mainly for motor application. Application current is normally AC current. 947, they have both AC or DC. And normally for NI8, especially when you install at home, there's no competent person, you don't need electrical auxiliaries. When I talk about electrical auxiliaries, you're talking about over voltage, okay, shunt trip, okay, auxiliaries like alarm, you don't need required for under NI8. For 947, you will be requiring to do monitoring and you can require to do control. So IEC standard marking, okay, this is a basic look of MCB. All right. So we have trademarks. Okay, each of the brand we have trademarks. You have serial number or reference number. Rated voltage, you can see here because this one is single phase. Rated current and tripping curve, you can see there C6 is a C curve 6 amp. Rated frequency is not stated here because it's following Malaysian frequency 50 or 60 Hz. If it's not 50 or 60, then the manufacturer have to declare at the product itself. Short circuit capacity, you can see here 4,500. Okay, you can go up to 10,000, 20,000. Wiring diagram, you can see on the top of the products. Ambient temperature, if it's not standard ambient temperature for Malaysia, you need to state it. If it's following, you need to state. Degree of protection is IP20. When I say IP20 is fingerproof, you can Google yourself what is ingress protection. Okay, so basically if IP20 is fingerproof, means your finger literally can't touch these live parts when it's on. Okay, but don't try to cheat yourself. I know some of you have a very small finger, so they have a standard size for it to test. Okay, I myself, I've tested IP20 when this thing is live, so I'm still alive and giving you a talk today. Okay, so application of MCB curve B, C, and D. Why these things are important? Okay, have you guys ever heard about starting current? All right, so take example like motors, right? Motors, maybe the current rate requires 32 amps, but the starting currents may go to 5 times, 6 times, 7 times, depends on the motor itself. If you are using a different type of MCB curve, but you are using the requirement rated current, then you may need to consider the type of unit to be used, B, C, or D, to ensure that you also cater for the starting current of the motor itself. So B, normally used for 3 to times to 5 rated currents, used for general use, water heater, sockets, outlets. C, 5 to 10 times, motors, lighting circuit, power circuit. D is more for transformer, sodium lightings. Okay, some motor will require D. So different. This is very important for you to design and to ensure that you don't under design each of the breaker for the type of load you are supplying. Symbol. Okay, under IEC C0NI and 947-2, okay, this is a symbol that you can see inside a single line diagram. Okay, so what is a single line diagram? Single line diagram is a design by consultant to show that the component, the cabling, the power, everything for each specific of the distribution box. So, but these symbols is normally not being used by consultant. All right. Why? Because they're lazy. Second, they just copy paste. Third, they don't know. Okay. So the best symbol is to follow the IC requirements. So when anyone who knows about this, when they see the design, they know what is this referring to. All right. So for half, and then this symbol will represent something. So semicircle is for magnetic strip, solenoid for current. Half square, I call it, is for thermal strip, bimetal, and overload protection. And then for this one is suitability for isolation and making and breaking. When I say making and breaking is for the on and off for the power contactor. So overcurrent, a current exceed the rated value. All right. So it can be divided into two, overload and fault current. All right. So let's go to overload. It's overload circuit which is electrically sound. The magnitude is small. A prolonged overload will cause the circuit to heat up and insulation to deteriorate. This is where it starts to caught fire and may present for a short period of time. If you recall in my previous slides, as I mentioned to you, there is curve BCD. So it is to ensure that you are selecting a correct type of breaker for the protection. And fast disconnection, the circuit is always not desirable because it may happen in a short period of time. So by definitions, okay, one MCB to protect one kettle. Okay, when you say overloads, you add another load there. So it exceeds the current rating. A simple terminology, you have 2.5 mm cable with a current carrying capacity of 24 amps. You have 3 sockets, but this one is not protected by a breaker. You put 10 amp load, should be no problem, right? Because it doesn't exceed 24 amps. You put another 10 amps, so its total is 20 amps, not exceed yet the current carrying capacity, but you put another one, so it reached 30 amps. So this is where overload occur, whereby too many appliances. It may occur because of the mechanical overload of motor or the motor jam. So what is the result? Cable heated in a prolonged period of time, which can lead to fire. So if you put an MCB here, it will detect an overload and it will trip the whole circuit to ensure that there's no effect to the loads or no effect to the cable itself. So thermal principle, if you recall in my previous slide, the architecture of a breaker, they have a bimetal element. Okay, this bimetal element is a two metal with different type of density, different type of temperature rise, whereby at a normal current flow, this bimetal will don't have any issue. But when there is an overload, the bimetal will start to bend. Okay, but it still not reach the trip bar. Why? Because it doesn't reach to the level of tripping. But when its flow increases, then it will touch the trip bar, then it will open the circuit. So this is how it looks like in a normal condition. In a trip condition, you can see the bimetal have bent and then touch the trip bar to open the circuit, whereby the power contact will open and then the arc created will be extinguished at the arc chamber here, or arc chute. And then fault current. A simple terminology, a current flows through an abnormal or unintended path. Okay, so normally current will flow from live to the loads and goes out to neutral. So that is the path that we want. But a fault will occur when it go to abnormal. Means there is a live touching between live conductor or live conductor to earth, all right, or to the neutral, and the magnitude is relatively high. So if you recall back my slides there's about I show you the marking of each of the breaker. They have 4,500. So this is where the magnitude to cater, because if you say, oh, it's just a 16 amp breaker, but when there is a short circuit, it can go to 4,500, 6,000, 10,000 amps in a blink of an eye. And fault current can cause extensive damage to cables and equipment. And fast disconnection is always desirable. Why? Because to ensure there is no issue, or there is no bad thing happens to the cable or to the equipment or to the people itself. So overall current, let's say this scatter is supplied by 10 amps with a MCB. It goes from live to load to neutral. So when a fault occur, take example, this live portion doesn't go to the neutral, it goes directly to the, doesn't go back to neutral, but directly take a shortest path directly to neutral. So this is where we can say electricity takes the easiest route. Instead of going to the load, it go directly to neutral. So this is where fault current happen, and the magnitude is really, really high. Okay, so take example, very simple. Okay, you have 3-pin socket. Normally installation in Malaysia, they will use ring circuit, whereby each of this from a MCB, they will go directly to the 3-pin socket, and then everything is installed inside the wall, so you can see where the cable is running. So take example, one day you want to hang something on the wall, then you accidentally touch live and neutral. Okay, left to neutral or left to earth cable, which causes by breakdown in insulation. And if the fault is high enough, it can cause fire due to the spark created when there is a short circuit, and it's possible for you to get electrocuted, something that you want to avoid in your entire life. Okay, so the magnetic principle, Okay, inside the MCB there we have a solenoid. A solenoid with if you see a magnet, right, do we have a polarity neutral and south, and not neutral, sorry, north and south. Okay, this solenoid inside, when the current flow at normal condition, nothing happens. Okay, but when the current flow increase, you will increase the magnetic field. So what happened when you take uh, uh, a magnet with the same polarity? It will push each other, right? So this is where the principle comes in. With the polarity, you can see here, same magnitude polarity, same polarity. What will happen? The solenoid here will be pushed and it will touch the trip bar to open the circuit. So this thing happens very fast, in a mere of millisecond. So how it looks like in a normal condition, you can see the plunger here or the solenoid here doesn't have any issue, but when the electricity increases, the magnetic field increase, then it will push a plunger to open the circuit. And then what happened? The power contact will open, and then the arc created will be extinguished at this arc chute or arc chamber. All right, so we go for residual current device. Okay, done with the MCB. So what is the residual current device or residual current circuit breaker? Is a electrical wiring device that disconnect a circuit whenever it detects that the electric current is not balanced, okay, between the conductor and return neutral. So my simple and layman term is, what goes into the load must come back at the same value. Okay, so if let's say goes to the load 13 amps sockets, so come back to the MCB must be 13, not more, not less. Okay, so this is how principle of RCD comes into play. So standards we are referring is only 61008. Okay, under Department of Standard Malaysia, it been adapted under IEC 61008 MS IEC. So you can see here, this residual current operated circuit breaker without integral overcurrent. If you recall, for MCB with overcurrent. So for overcurrent protection, it been taken care by MCB. For leakage current, it been taken care by residual current device. All right, by definition, it's the same. So standards 61008 for RCCB, 61009 for RCBO, Earth Fault Relay or ELR, and they have guide to use of RCD. This is all the standards that you need to refer. And then MSIC 61543 EMC requirement. So these standards, this last standard come into play for the past 2 or 3 years, whereby if you happen when there is a issue when a guy bring a walkie-talkie to the panel room, power room, when he use the walkie-talkie, the RCCB will trip due to the electromotive force. So this is where under Suruhanjaya Tenaga, they requires all the RCCB to comply with the EMC requirements to ensure that this nuisance or this interrupt things can be avoided, when to ensure that the safety and continuity of protection being provided to the end user. So talk about RCD, it's a generic term actually. Okay, it can be divided into 4 or 5. You can see that as the RCD, you will have an RCCB, or the old term we call it ELCB. If you go to the store now, to any of the electrical store, they will still talk about ELCB. So ELCB is the old term. New term, they call it RCCB. ELR, okay, normally used for high power. Portable residual current device or socket residual current device, which you can see on the labs, or portable when you buy a very expensive extension socket, whereby they can say they are protected with RCCB or ELCB. Then you will have RCBO, MCB plus RCD. So in electrical terms, residual current, what they mean is a vector sum of value of current flowing in the main circuit of an RCD. So when you say vector sum, if you divide it into 5, the total must be the same of the incoming of the power. So it's very simple. Whatever goes to the load must come back at the same value. So earth leakage protection, this is a terminology, a very simple example. Okay, so you have RCBO or RCCB. So you have motor provided from the transformer, you have an isolator, but this one is when there is a leakage occur, it will go flow to the system. But when you have no residual current device, what will happen to you? If you accidentally touch it, you become an earth. Okay, then you get electrocuted. With residual current device, when there is a leakage, it will open up the circuit automatically and ensure the safety of the user if they are touching it. All right. So this is where it's very important. So how it operates is very simple. They have in the RCD, there we have a toroid and a relay. Okay, relay, we also have a same principle like the MCB where we have north and south poles. Okay, and then you can see here, this is the live portion, this is a neutral portion, whereby live goes to the load, neutral come back. It's the same value. Take example, if let's say you go 10 amps, come back 9 amps. So what will happen? The induced current will increase, electromagnetic flux there, and then with the same polarity, it will open the circuit. The relay will open the circuit to ensure that there is safety continuity to the user itself. So you can see it's a very simple mechanism, but it protects people every single day without we are knowing it. So under IEC 61008, the clause, this is where I will not go into deep each one of these, but this is the clause, but every manufacturer have to comply to ensure that the product is safe to be used, and to ensure the continuity is and the performance of the products applies with the standards. So important parameters, normally you can see a breaker, RCD. You can see the nominal current stated there. You can see the sensitivity, 6 milliamp, 10 milliamp, 30 milliamp, 100, 300, 500 milliamp. Class GNS, general and selective. Type AC, A and B. I will go in depth what is AC, A and B. And then 2 and 4 poles. All right. Then each of the RCB must comply with the R delta NO. We call it non-tripping current, which is equal to 50% of the sensitivity. Why this come into play? Reason is this RCCB, when it connects to the load, some of the load we will have their own leakage. Okay, especially those loads we call it like LED. When you turn it on, they already have a leakage. So that's why Aldeatano must come into play for every manufacturer to ensure that it will not cause a nuisance tripping to the whole system. So IEC marking, same like MCB, you need to have a trademarks, you need to have a manufacturer reference number, rated voltage, you will have a frequency, rated current, as I mentioned, 40 amps, operational current, sensitivity, this one is 100 milliamp, making and breaking capacity, this is for the power contact, IP20, fingerproof, selective, if no marking for normal G type, test button here, this is a test button, and the wiring diagram, and also AC, A or B type. Okay. So class of RCD, AC class is for pure AC current, where it applies for electrical device with non-electronics. So non is a linear loads. All right. And then A class is for pure AC current and pulsating DC. So anyone knows what's a pulsating DC?
No.
Okay. You guys are using a laptop right now.
Yes.
Yes.
So you see the black box there?
Yeah.
Yeah. This is where they have a converter.
Oh.
So those converters, your laptop are using a DC, but not what I call it is not a pure DC like total batteries. So it applies for electrical, for electronics and non-electronics. So right now, you will have your mobile phones, your laptops, your whatever converter that requires from AC to DC. Okay. So normally in standard installation nowadays, they still use AC class. So what will happen when you use AC? Let's say you get, let's say there is a leakage after the converter. What will happen? It will not detect and you still get electrocuted. So it's very important nowadays for me, even my manufacturer, to educate the consultant, to educate the people. You need to shift from AC to A class. Why? A lot of component nowadays, lot of loads, lot of equipment using nowadays as a converter inside. So to ensure that you are still protected when there is a leakage occur. Okay. So take example, if you follow some of the news a few years back, some people got electrocuted when they're using a mobile phone while charging. And why the RCCB did not trip? Because they're still using AC class. They're not using A class. So this is where it happens. And then shift to B class. So this is where you have everything detected. Normally B class, when you have a solar. Nowadays you can see at home or any office building that we have a solar panel on the top. So to ensure that you are protected, you need to use B class, whereby you can detect everything, every leakage that occur by the loads. Okay. So you can see here, detect pure AC, pulsating, and smooth DC from battery. So by definition of fault current, this is where MCB comes into play. Earth leakage current, a current that flows to an extraneous conductive parts. Okay. So protection by RCD device can be by three components, which is for direct contact or indirect contact, or protection against fire. So for direct contact, it's very simple. A contact of person of livestock with the live parts. When you see an open cable, you accidentally touch it, then we call it a direct contact. Then you get direct electrocution. Okay. When I say indirect contact, you will see you are touching. Okay, normally this happen like normal. You can see this when you're touching the washing machine, right? So this is where the indirect contact happen. Okay, when there is a leakage or the cable faulty, the exposed conductive part, you accidentally touch it, then it become live under fault condition. This is where indirect contact happen. So level of sensitivity where we apply for RCCB, 10 milliamp for school, labs, test workshop, water heater. Personal protection 30 milliamps, 100 milliamp for lightings, 300 milliamp and 500 milliamp for building or fire protections. Okay, why this sensitivity is very important? Okay, some of you may say 10 milliamp is very small, 30 milliamp is very small compared to 1 amps. You can see on the bottom there, 1 milliamp is equal to 1 divided by 1000 amps, which is 0.01 amps. But your loads, maybe an amp, 8 amps, your 13 amp sockets, the mobile charger that you put in this morning is 13 amp, right? So this is the effect of electricity to human body. At 0 to 10 milliamp, you only have perception. Means when you get electrocuted, you still can let go. You will feel the electricity flows to your body. From 10 milliamp to 40 milliamp, you will have a muscular construction. This is where a level where you cannot let go. Okay, where you cannot let go, your muscle contract, you will still hold the thing that provided electricity to your body. At 40 to 80 milliamp, you will experience burns and respiratory alert, means you have difficulty in breathing. And some of the muscle will start to burn. And then from 80 to 1000 milliamp, which is 1 amps, you will have severe burn and you will have heart problem. More than that, you can go for cardiac arrest or heart attack. So may I remind you, 1 amps equal to 1000 milliamps. So you can see as small as 10 milliamp is our body can cater for electricity or leakage that flows through our body. More than that, Assalamualaikum. So one question, do you guys use water heater?
Yes, of course.
Yes.
Okay.
Yes.
Okay. At the water heater itself, what it say at the front of the water heater?
They say about
No, see, people don't bother.
Yes.
warning.
Better to see.
Okay, it's at the front of the water heater that we say ELCB, included, ELCB protected. Okay, it is a requirement that every water heater company to put an ELCB or RCCB integrated inside the water heater. But take note that some people we have the idea that, oh, I do have a water heater with ELCB inside, so I don't need to add another 10 milliamp protection. 10 milliamp protection when I use a water heater. It's a wrong impression, whereby you need to put another 10 milliamp RCD at the final distribution panel to protect the whole system. Because the ELCB at the water heater itself is to detect leakage at the water heater only. But what people do not know that when there is a leakage in the electrical network system, it can travel from the washing machine, from your fridge to your water heater while you are using it. Okay, so it happens for the past few years. People get electrocuted. Why? Because they don't put additional protection. The ELCB are not functioning. ELCB at the water heater is not functioning. So if they put another 10 milliamp protection, then we have additional protection for the whole system. And then just to remind you, water is a great electricity conductor. So it may happen. When the things happen, it will happen. Okay, so take sure that after this session, take a note, go see for your panel, go see to your water heater, do the LCB still function? Normally they have a button there to test, and then goes to the final distribution or your DB box, check if it's only protected by a breaker or with an RCD. If not, please add, because this is part of the campaign that I've been done from 2017 to ensure that people install a water heater with a 10 milliamp protection to ensure that there's no electrocution happen to the user. So far until RCD, okay? Any question?
We have some question in the comment section, in the chat section. From Izati Sulaiman. She asked, hello Encik, I'm slightly curious. Say if the trip level in the MCB is already broken in the first place. So my question are, how do we testing on the MCB to know it functioning well?
What is it?
The,
Can I see the question?
in the chat section, yes. Yeah.
Okay, if the MCB trip level is already broken in the first place when purchased, so first thing you need to change it directly. Okay, but if let's say because the trip is the function of the trip level is to turn on and turn off of the breaker. Okay, but if let's say you are in the middle of the night, okay, there's no store open, you still need to ensure that it still function, then you can force it turn on, and then you can see the lever is in the turn on position on the top. So normally it's a simple, when the lever at the bottom is turned off, when the lever on the top is turned on. And then what other things you can do, you can use a multimeter from the top and bottom to ensure that there is a continuity at the breaker itself. Because I believe, Izati, you have no issue because you're electrical student, right? You will know how to use a multimeter. Okay. And then second, if you already installed MCB in a home and it has cost damage, who will take responsibility for that? Okay. If we already installed an MCB and has malfunction and cause damage, okay, it can be either two things. Either you take the responsibility or damage by yourself, but normally because it's due to the installation, or if let's say it is due because of TMB, then you need to call for TMB, because normally this is a normal case. Okay, it's not a TMB fault, but normally in a rural area or not in the city area, sometimes the voltage may fluctuate, and when it fluctuates really high. Okay, normally like ours 220, 230, it can go to 27, 28. It happens, yeah. If you see any wireman, you can ask them. It's a common thing. So if you find out it due to the supply from the utilities, you can call them, ask them to claim. But they will send people to check to ensure that it is caused by them, not because of the installation itself. Okay.
Thank you, Cik.
All right. Any more question? I think some of you may be scared now because you use water heater every single day. Okay. A new house, residential house, which surely have an RCD as a protected, means the developer will install a 10 milliamp directly at the panel at the distribution level, and then you just install a water heater, connect to the 10 milliamp RCD. But old house, normally people, we don't have it. And some of the installation is sad because some of it are tapping from the lighting circuit. That is super dangerous. If you find out, please call a wireman, or if you can do it yourself, if you have a certificate for wireman, please do a proper installation. Even me myself, I'm living in a 20 years old house. Okay, so when I install a water heater, I pull the cable myself from the distribution board directly to the water heater in the bathroom, to ensure that I'm protected, because we use the water heater every single day. So let me continue. Okay, so you can see my slide, right?
Yes.
Yes.
Yeah.
Okay, so we have done with MCB, we done with RCD, and then the last component that normally we see inside is the SPD. Okay, surge protective device. So got a bit of recap. MCB is to protect against overload and short circuit. RCCB is to protect against electrocution. Just take a simple layman term, electrocution or leakage protection. So another one added is a surge protective device. Okay, so the problem that we are facing now in Malaysia, there's two problems. We have lightning transient and switching transient. Okay, so this is the thing. Transient means is a lightning with a lightning strike. Switching is based on the motor. Okay, World Lightning Transient Map. This is where I get from the meteorological department. Malaysia estimated we have 15 to 30 lightning strike per kilometer square per year. So if you go to the Malaysia meteorology website, you can see they will divide it each of the location, maybe they will show PJ, Segamat, or any of the area, which the number of lightning strike per year. Okay, and this lightning strike will increase year by year due to the environmental, due to the weather condition. So Malaysia is one of the, you can see here in the map, in the red color, you can see Malaysia is one of the highest area with a high lightning strike. So when I say lightning strike, you can divide it to direct or indirect strike. Direct strike, it means it direct goes to your power line or goes to your house, or indirect strike, it can goes to other area, but due to the resonance created, EMF created, it can also travel to your house. So lightning strike is super damaging, and when it happens, sorry, TMB won't cover you. It adds your own expenses. So switching transient, basically a motor on and off, whereby it will travel to the network and goes to your equipment. It will not affect immediately, but it will significantly reduce the lifespan of your equipment. So take example, you have a TV, a 72-inch TV, LED TV, smart Android TV. Suppose can be used for 2 to 3 years, but due to switching transient, it shorten the lifespan to 1 year. Then you blame the brand, Samsung lah, whatever, cannot boleh pakai lah, murahan, tipu orang. But actually, this is the thing that happens. Okay, and it's worrying because you can see nowadays a residential or property development is located nearby a factory area. You can see a lot nowadays. So what will happen in the factory area? They will have a big and large motor. And take note, this thing is connected, so it can travel from the system to your electrical equipment. It will not blow up your TV, but it will shorten the lifespan of your TV, your computers, your PS5, or whatever things you connected. All right. And this thing happens every single day, continuously. Compared to lightning, it happens maybe 1 week once, 2 weeks once. Okay. So under IEC 61643 is a device to limit transient over voltage and divert surge current. All right. So under standards, it been adapted to MS IEC. So this is the content. As usual, I will not go into depth, but for manufacturer, any brand have to comply with this requirement. All right, type test, routine and acceptance test, everything have to comply to ensure that the SPD is safe and is performed as is was needed. So I just go to the core things. Okay, you have categories and classification. For class 1, for direct lightning current or lightning strike. Class 2 against indirect. And then class 3, again, switching over voltage or for sensitive equipment. But commonly people will install class 1 and class 2 at the distribution box. Okay. So when I say direct lightning current, basically you have a lightning rod. I assume you guys know what is a lightning rod. In the building, there we have a lightning rod on the top. So it prone to a direct lightning strike. So like me in the technical paper, we call it please strike me. Please strike. When you install a lightning pole on the top. Okay. When the class 2 for indirect, you don't have a lightning pole, but you are located in pylons or in a plains area or nearby to a high building. So the lightning will not strike your house, but it will strike the building, but the resonance created can travel to your house. So that's why you need to have a last 2. The important parameters, when you say an SPD, you will need a nominal discharge current, maximum discharge, protection level. This is where the SPD will start to operate, and continuous operating voltage, and then the test pulse. Okay. So how does an SPD works? Okay. If you take an MCB and RCCB now, you turn it on, you can see there is a continuity. You take a multimeter, there is a continuity on the top and the bottom. But SPD, there is no lever. Okay, on and off lever, there's nothing. It's a plain thing. But and then without operate at the common condition, it is an open circuit. Okay, it's not a closed circuit. So at the normal condition, you can see here is an open circuit. Maximum voltage is equal to the system. But what happens when the main voltage exceed the maximum permanent voltage? It will automatically become a short circuit. Instead of the surge traveling to your loads, it will divert directly to earth. This is where it comes into play. And normally for SPD, let's say 230, right? Normal operating is 230, and then normally for SPD, the maximum permanent voltage normally like 275 or 260, depends on the manufacturer. So let's say the voltage exceeds 275, then it becomes short circuit instead of open circuit. Then the excess voltage that flows will not go to the equipment, it will go directly to the earth. So your equipment is safe, and then it will ensure that the network is still protected. And then SPD is a self-sacrifice device, which means after a few big strikes, it will start to kaput, tak boleh pakai dah, then you need to change to a new one. So every SPD, we have an indicator at the front. Normally white is operating, white or green, and then red, you need to change. But the frequency of change will depend on the location. Maybe a few years. Okay, even myself, I install one, I have no issue, I operate until now. Even my mother house, I install one, it still operate after 5 years. The indicator haven't turned, even though the location have a high lightning strike. Okay. So how to select? Okay, for very strong risk, type 1 or type 1+2 is an exposed area where building equipped with a lightning rod, as I mentioned, with a lightning rod. Okay, and then building is totally or partially overhead power lines or have pylons. Okay, so you need to put type 2. Normally you can see in a big urban residential area that we need to install a type 2 SPD. And then if a self-generated search, okay, goes to the sensitive equipment, then you need to put a type 3 SPD. So this is how you select. Or by Schneider Electric, we give this type of selection. Do you have a lightning rod in the building, 50 meters? If no, you go for type 2. And the risk level will be need to access. If the building is located in urban or suburban group area, it's a very low risk. Medium, located in plains. When I talk located in plains, one building and the surrounding is like paddy field. Okay, so it's considered as a plain. So it's a medium risk or high risk, located in a special risk area where there's a pylon, there's a high trees, mountainous region, mountain peak, okay, or nearby to a high building. So this is where the risk is high. For type 1 or class 1, you have normally in a manufacturer, we have type 1 or type 2 combined together, and then depends on the earthing system. If it's not an IT earthing system, then you need to access where is it located for office, schools, for hospital, for IT center, for museum. So this is where, like I say, the first start point when you want to select an SPD, the select the correct SPD for the building. How it is installed, class 1, class 2 first, and then class 2 or class 3 before the equipment. So if there is a lightning strike or surge, these two will cater first, they will divert to earth or limit. And then if there is access, this class 2 or class 3 will take into play, whereby it will also divert or limit the current voltage, will go to the load or sensitive load. Normally people will install this 3 level when we're talking about data center, okay, where they have a lot of sensitive electronic equipment, we can easily damage when there is a lightning strike or surge. So I stop here. SPD, any question?
Not yet.
Okay, SPD. Okay, just a point here. SPD is not a requirement in the panel, but starting 2020, early of 20 February, it is a must to install an SPD in a house. It's a requirement by Suruhanjaya Tenaga to install an SPD. So for new development, they will need to install. For existing installation, the Suruhanjaya is advising a lot of, the end user or the house owner to install an SPD to provide a full protection in the electrical network. All right. So we go to our last topic, which is e-mobility. Okay. So global environment challenge. Okay. The fact is, energy demands will be multiplied by 2 by 2050, and electricity demand will be rise by 2 times in 2030. But the needs for the carbon emission must be reduced by 2 times to avoid dramatic climate change. You can see previously, before the COVID situation, the polar cap been melted. But during the COVID situation, during the PKP, whereby the whole things goes to the normal. So this is a thing that we need to continue even after the business, the new life of working have been continued. All right. And then not just the environmental climate, transportation is responsible for 25 to 30% of carbon dioxide emission in the world. Okay. So target for transport sector to reduce by 60% greenhouse gas emission by 2050 in Europe. Okay. And then 100% of new cars must be fully electric by 2035. Okay. Malaysia is not very popular because our government did not do anything about the EV. So we as a manufacturer, as an NGO, we push hard to ensure that people go to the new technology to ensure that carbon emission is reduced. Okay. Not for us, maybe for our kids, our grandchildren. We need to ensure that they're also enjoying the life that we have when we are young when we are growing up. And electric vehicle can also drastically reduce background noise. All right. So cleaner mobility is mandatory to reach climate goals. Okay. Each of the countries here have been announced. So take example like Ireland, if I'm not mistaken, they will not Ireland. I forgot which country. They are going to ban petrol car or diesel car in their area. So people have to move to electric vehicle car. Okay. Even China is one of the leader now. Okay. Sweden to ban. Even our neighbor Singapore are planning to ban ICE car or petrol car or engine car. If I'm not mistaken, 2030 or 2035. Okay. So everyone are going to that direction nowadays. Okay. But EV adoption is limited. Okay. Why? Because total cost of ownership. And then the range. And also the problem nowadays, the charging station. All right. So incentive from government is very important. Okay. New EV model car and deployment of policy. Okay, you can see our neighbor like Indonesia, Singapore, Thailand, they're really pushing on EV. But Malaysia, we're still hoping that the government will rethink and also put some effort in helping to the adoption of the EV car. So introduction. So what is e-mobility? It's a utilizing of electrical powertrain. Okay, when I say powertrain, the power that be derived from the car itself, it comprises of electric, conventional hybrid, and plug-in hybrid. Okay, I will go into that. Some of you maybe doesn't know about this. Okay, demand due to improving battery density and technologies. Okay, include unmanned aerial vehicles. Okay, electric bikes, helicopter, planes, hoverboard, ship, and anything that use electricity. Global EV stocks about 7.2 millions, and 7.3 million chargers nowadays, but it will increase based until 2030. And what's the benefits? Environmental friendly, you can reduce carbon emission, you have legislative compliances, and reduce cost of ownership. All right. So my question: have you guys seen EV car before? Or PHEV?
Yes.
Yes.
Inside
What
YouTube.
car?
Tesla
The
Model
small
S.
car, the cute
Tesla.
one.
Tesla.
Model
Okay.
S.
All
Wow,
right.
never seen Tesla.
All right. Another one. BMW. Everyone seen it? i3. Nissan Leaf. Okay, some of this car that I show here is not available in Malaysia. But you can pinpoint which car is you have seen it in Malaysia. But for Malaysia, we have Tesla, which is unofficially bring in Malaysia. You have Renault Zoe. You have BMW i3. You have Nissan Leaf. You have Hyundai Iconic. So this is most of the most popular car you can see in Malaysia. All right. And then you will have PHEV, we call it hybrid EV car, whereby it still runs on electricity and also petrol. Okay, you can see it mostly on BMW,
Honda Civic.
Honda Civic. They still doesn't have the full. Okay, you need to take note. There's 4 type of car in the world. Okay, all right. There's an ICE car. It runs on petrol or diesel. Second is a self-generating we call it PHEV. Okay, like Honda, like Toyota, but it doesn't require to charge. When you move the car, when the car travel, it will charge the battery by itself. Another one is PHEV, whereby you need to plug in a cable to charge the battery, and it still run on petrol. But you can do a selection that you want to battery or you want to run on petrol, but the battery is small. It can run maybe about 50 to 60 km only. Then you have full EV, whereby it runs entirely on the battery itself. So my question is, yeah, you have seen one. Have you drive one?
No,
Wait,
never.
Yeah. Are you a occasional driver or you're a proud EV owner? I don't know. Maybe some of lecturer here, maybe Dr. Ann have buy one. I don't know. Okay, so What is an EV vehicle? It's a rechargeable electric vehicle. So you can see on the left is a battery electric vehicles, BEV, or people should call it EV. So they rely entirely on the battery to provide power. Compared to plug-in hybrid PHEV, which you can find in the market, their batteries can be recharged but have conventional engine to run. So both we have an AC charger used on board, okay, and then convert current into DC battery. Okay, so this is where we call it electric vehicles. And then another one, as I mentioned, conventional car called ICB or hybrid EV, which cannot be charged using plug. Okay, so it charge when the car is moving. So various needs depend on the various segment. So when you have this EV car, you will need a charger. Okay, so this charger, if it's not maintained properly, it will cause issue to the user. You can see here for residential, they use AC charger with no meter, limited energy. Gas station with a fast charge of DC using this one. Okay. Outdoor use, you can use either from AC or DC charger. Public parking, on street, they will need to use a DC charger. Public service of fleet charging is more suitable to use a DC charger instead of AC charger. So if it's installed in residential, should be no problem because it's one-on-one, one house, one charger. Gas station also should have no problem. When you go to a fleet charging public, it cause an issue to the user whereby the demand may be rise. Okay, it may not happen now, but you will see more and more issue we face when this charger installed a lot in the market. Okay, so charging technology, as I mentioned, you have two types, AC and DC charging. Okay, for AC, it can go from 3.4 to 22 kilowatt. For DC charging, can go up to 150 kilowatt. Doesn't care the price level. Charging time from AC to DC, very big difference. Charging time from AC 4 to 7 hours, depends on the car. DC maximum is 1 hour. So residential use, AC use in residential, work, shopping or leisure. DC, which will require people faster charge and go. When I say charge and go, means you cannot, if you go to North-South Expressway, you can see some of the R&R, they will install a charger, or petrol station, they will install a charger. So you cannot expect people go there and spend 7 hours for the car to full charge. So that is where DC charger comes into play. When you plug in, 30 minutes, 1 hour, the car is fully charged. You can continue your traveling. And then the difference between AC and DC charging. AC charging is based on battery or power on the onboard charger, but DC charging directly to the battery based on the power of a DC charger. You can see here, DC charging directly to the battery, AC charging directly to the onboard charger, goes to the battery. And both EV and PHEV have your own onboard charger equipment. Okay, so that's why the difference between the timing 4.7, because it goes to the onboard charger, but this one directly to the battery. It became faster. So how to stabilize? When you have a lot of EV charger in the market, when you install in your office, we need to stabilize the grid with an EV charger. You can see here on the top right, energy consumption goes to the balancing of the system, goes to the cloud computing due to energy consumption. All right. And then grid technology, unused power from EV back to the power grid. Okay, which you sell back again. It can perform to balance and store renewable energy, especially those houses who have a solar panel, whereby you can charge and you can feed back to the power lines. Okay, EV battery is another source of storage. Okay, usage to the limited duration of time. Do the challenge to ensure EV charger have minimum energy when they need it, and driver can determine the minimum percentage of battery they needs. So benefit of vehicle to grids towards to zero carbon emission and lowering cost of ownership of EV. Okay, as I mentioned here, stored and mobile energy released at the network during peak times and renewable energy from other vehicles at night. So at nights when they're charging, they use renewable energy to charge the car. And then plug and charge technology. So this is where the new technology comes into play, whereby nowadays, if you want to charge an EV car, what you need to do, you need to buy the access card from Green Tech, Malaysian Green Tech Technology Corporation. It's one of the government bodies in Malaysia. You need to buy the card. Only with that card you can charge. So with the new plug and charge technology, okay, you can charge without physical authentication. Even the car itself will recognize and give information to the charge point operator, which the one that manage the charger, and then they can just directly charge. Okay. And then it comes with a crypto system, algorithm system, where it can detect what car is using, who is the owner itself. So it's a very advanced technology. Okay. So the reason that I'm exposing this thing to you guys is when you go out there, you know about this thing, and you know it's a trend, it's a demand, and I believe in 10 years time, Malaysia will go directly to EV vehicles instead of ICE car. Okay, and then we go to the microgrid. Okay, this is the alternate source of charging. I think you know about microgrids from the TMB version. Okay, EV needs, you can see here, EV charger, it will add stress to your local grid, which is making difficult to monitor. So what you do, you upgrade your low voltage and medium voltage equipment to optimize your charging requirement. Okay, and then you distribute. Okay, you upgrade your LV and MV equipment, which is very costly, or you can distribute energy resource, add local energy resource using a PV, photovoltaic, battery, energy storage to charge your vehicle without any extra cost. And you have a controller to monitor and take control of your distributed energy resources. And then everything here nowadays, if you go for 4.0 industry, you go for connected cloud service. Everything is cloud, connected to the cloud, whereby you can use any of the software available in the market to do monitoring via supervision. You can control up to the level where you can turn off the charger without going to the car itself. So this is where it comes into play with the technology nowadays, with the cloud computing. Next, we have a load management system. Okay, compared to the cloud, this is another thing. Okay, let's say you have an office building. When you go to the office, okay, you have office building, it requires 15 to 220 kilowatt, lot of charger, which is increase the demand from 8 to 25%. Okay, normally EV charging causes the rise of energy demand. Okay, what will happen when you exceed the overloads? You will have blackouts. You will get penalties from TMV because you exceed the subscription power monthly that you have been subscribed with TMB, and you will have energy billing rates. Okay, this is what I call a waste of energy. Why? Because you are wasting a lot of energy to charge the car without using any smart system to handle it. So for load management system, not just Schneider, any brand also will have this type of technology, whereby it helps to distribute available power evenly among charging stations, whereby the user can create a smart rules. Okay, you can maximize the quantity of service in all building. Okay, take example, there's a building, they have a 10 EV charger. So when all 10 is occupied, if they don't have a management system, it will create a spike in the electricity demand. Okay, so with the load management system, what it will do, it will regulate the power to ensure that it will not exceed the subscription power, and also regulated all of the charger will be maintained at the minimum level of requirement. So take example, let's say at night the power usage of the building is lesser. So what it will do, it will provide more power to the EV charger instead of giving the power to the building itself. So this is how load management system works. So they have two types, as I mentioned, static mode and dynamic mode, whereby static modes, you will have a current set point to ensure you don't exceed. So take example, normally for a car to be charged, it will use 16 amp or 32 amps. Okay, and then we have either 7 kilowatt, 11 kilowatt. So using a static mode, you will set in the system, okay, for this electrical charging, you will not go up to 7, you will go to 3.5, 3.4 only at the whole day. Or you can use a dynamic mode whereby with the load management system, it will allocate the power based on real time. So as I mentioned before, at nights, lesser people use the office building, but you come and charge your car, so more power will be driven to the car itself instead of the building. But during the daytime, when the power demand is high, then the power will go more to the building instead of to the car. At the end, what is the goal here? To ensure that you will not exceed the charging subscription power that you've been used with TMB, and you will not higher energy billing rate. This is where when you graduated, when you work, whatever you do, people will go for safety, and then less cost, less capex, and less opex. Okay, capex is a capital expenditure. Opex is operating expenditure. So this is where it comes into play. Okay, this is the same thing. Sorry. So I think that's all from me. Any question from you guys?
Terima kasih ucapkan kepada Cik Mazliazhar atas penyampaian dan perkongsian tersebut. Jadi kita teruskan majlis kita bagi sesi soal jawab. So, kalau ada soalan boleh ajukan kepada Cik Mazliazhar.
Okay. Okay, soalan, is the electric vehicle solution for our mobility in the future? Yes. Okay, maybe some of you follows the news. People go for hydrogen fuel cell. Okay, so nowadays there's two things that go for to reduce carbon emission, which is EV car, which is really people Elon Musk is pushing on the EV car. Another one is hydrogen cell fuel. So nowadays electric vehicle is the solution, not the hydrogen, because hydrogen is very expensive. But they're still improving the technology. But I will rather see that EV car in the near future, 5 or 10 years down the road. Why? Because every country is adapting it. Every country is want to ban petrol or diesel car in their country. So you can see that the EV car demand will be rise. Even in Singapore itself, they have started with what we call it electric vehicle adaptation scheme. It's quite rewarding. When you buy a car, you can get about 60,000 K of tax reduction. So Malaysia still doesn't have it, but we are looking and we are pushing using the NGO to start Malaysia to also venture into this and also pushing it to the market. So next question, if electric car runs on energy to move, needs a place shop, but the nearest area the power supply is So is there any other way of energy backup for this car to move? Or sadly, they only run on electric vehicles. But what you can do is the car itself is connected to the mobile apps. Okay, it's very advanced. So it will give you a warning, maybe 50 kilometers that you need to charge. And then all of the charger can be checked availability based on the location itself. Okay, so when you go, you can just install in your Android apps or whatever, Jump Charge or Share Recharge. So when you open the app, you can see the location of the charger. So immediately, and at the app itself, you can see the charger availability. So make sure that you take note your car power every time you're using an EV car.
Hello Cik Mazli. Saya Abdul. So saya nak tanya soalan. Soalan saya panjang sikit lah. Tapi dia related pada saya punya FIP. So saya nak tanya pasal earthing. So earthing road ni kan dia connected dengan earth punya bus bar dalam DB box. Okay. So so as we know, function asal function punya earthing road adalah to bring out the leakage current from inside house to the ground. Okay. Tapi problem dia adalah bila strike.
Hello? Hilang pula.
Commonly-nya dia tak ada lightning arrestor, betul? Hello?
Ya, dengar. Dengar. Okay.
Cik Mazli dengar tak? Okay. So problem dia bila strike happen, commonly residential house tak ada lightning arrestor. Okay, so bila strike happen, dia berkemungkinan di strike pada rumah, pada pokok, jalan, tanah, tempat-tempat yang boleh di-strike lah. So saya ambil situasi di-strike pada ground, okay, pada tanah. Bila di-strike pada tanah, electricity yang dia generate tu sangat tinggi, okay. So dia akan cari konduktor yang paling terdekat. So iaitu earthing road tu lah. So anda katalah earthing road tu adalah earthing road rumah kita. Bila dia strike tu, electricity tu dia akan pergi pada earthing rod dan jumlah dia tu sangat tinggi. Sebab earthing strike ni tak silap saya dia boleh hidupkan satu taman rumah dalam 10 hari 10 malam macam tu lah. Dia punya electricity. And then tak sempat dia nak earthing rod tu nak hantar pada tanah, lebihan electricity yang di-generate oleh strike tu dia akan masuk ke dalam rumah.
Betul?
Dia akan masuk ke dalam rumah melalui wire earth tu lah, masuk pada terminal basebah, connect pada appliance connect pada RCCB, MCB, main switch apa semua tu. And then dia akan rosakkan TV, aircon, kipas apa semua. So saya nak tanya Encik Mazli, apa the best solution Encik Mazli nak cadangkan? Sebabnya untuk dia tak relevan untuk pasang lightning arrestor setiap rumah pada residential house sebab dia melibatkan kos. So apa Encik Mazli boleh cadangkan the best solution lah from Encik Mazli? Thank you.
Okay, the best solution untuk kalau maksudnya kalau macam ni is what we call indirect strike lah. Indirect strike
betul.
maksudnya lightning strike sebab memang kat rumah sekarang, tapi secara jujurnya kebanyakan rumah dah setiap pasang. Saya pun tak tahu kenapa. Okay, sepatutnya setiap rumah tak perlu pasang. Dia hanya perlu pasang lightning rod. So when we call it indirect lightning strike, yes, it can travel to your earthing, it can go to your equipment. So the best thing to install is to ensure that your earthing rod resistance is low as possible. Low as possible. How to ensure to achieve that? You need to have a very good copper rod with a minimum depth. Okay, normally kebanyakan installation dia tak ikut spec. There is a minimum depth of requirement to install the lightning rod, and then it's a pure copper. And then it's a pure copper because nowadays banyak contractors cuba cheat, dia guna mixture of copper. Okay, it happens, and then need to ensure that you install an SPD directly. So if let's say you ada 2 panel or you have 1 panel, big panel, so you need to have a type 1 or type 2, or if required type 3. So if you install that to the system, it will provide a full protection. But don't install an lightning rod on the top. Okay, lightning rod on the top is basically bagi saya inviting untuk strike. Okay, so this is one of the steps. Need to ensure that you have a proper earthing and also a protection for the whole system.
Okay.
Oh, ada satu lagi. This is based on my experience. Saya dah jumpa dengan seorang engineer dulu, judgement. Apa dia buat? Dia buat double earthing. So in front of the house ada satu, at the back of the house ada satu. Proper earthing.
Faham. So dia punya resistance akan lagi rendah maksudnya.
Makin rendah. It also can do.
Baik.
So saya sambung ya.
Terima kasih Cik Mazli.
Okay. Hello sir, I have a question. This is vehicle nearly 40% of the world city generated micro power. Okay, this is where in my presentation, the demand of the city will multiply by 2. But this is where the load management system comes into play to ensure that even though the demands rise, but you are managing the electricity efficiently. Okay, what happened nowadays? People just install a charger. They install charger and then they don't care what happened. As long as I can charge my car, should be no problem. It happens in residential. What happened in an office building in the fleet charging, where the resistance is high, where the demand is high. So you cannot stop people using coal power. You cannot stop people using whatever coal power station to generate electricity. But when you use efficiently electricity, you can reduce the high demand in the generating area. So that's why it comes into play. Even any of the manufacturer macam saya Schneider, we have come out with a management system whereby you can effectively manage the power. So you still power using the same, but you can feed to a lot of loads. You can feed to your, and also another renewable energy like PV, okay, whereby you can generate, you can store. So this is a thing that can help to reduce the kebergantungan kepada coal power. Alright. And then my next question, follow this product more people. Will consist effort ban petrol juice EV. Doesn't it going to reduce our national income and affects our oil and gas industry? This is a very tricky question to answer. Okay, it may affect our oil and gas industry, but we need to take note on the carbon emission in the world, because sadly, we are still lucky we are living in Malaysia. If you go to China, you can see even the air there is very polluted. Why? Because of heavy industrial. So not people maybe not going out of job. With EV, it will create a new job, an EV factory, an EV charging company that will emerge, and they will sell the charger and also the load management system, the management system of the power itself. So that's why nowadays people go for Industry 4.0. As I mentioned this many times, you go for cloud computing. So go to that direction. It will create more demand nowadays. Even the residential nowadays, in house, in your switches, your socket, okay, socket lampu ke whatever, people go for automation. So go to that direction. Find a way to go to that direction instead of going to oil and gas industry. I know there's a message to all of the graduate: when you go to the oil and gas industry, it's more rewarding, gaji lagi banyak. Okay, but need to also think where you want to go after you graduate. Not just for oil and gas. There's a lot of opportunity out there, as I mentioned to you. Isn't me myself? I go to the marketing and technical. I didn't see this role as a future role for me, but as long as I go, I try, I see there's a lot of potential, because new emerging technologies coming every single day. Okay, and then they will require a marketing and technical person to help support sales, to help drive the business. So don't talk about oil and gas industry anymore. Okay, go for another automation, solar. It will be more rewarding and it give you more exposure to the market. Okay, and then if the protein if the popularity of using electric car is increased in the future, if the user travel for a long journey, from my view, I think all the petrol stations will provide the car journey will be too crowded, because of one car it takes 30 minutes to 1 hour. Can I ask your opinion? Okay, to be honest with you, sadly in Malaysia, full EV car there is about 1,000 units so used in the market. They have about 10,000 PHEV car in Malaysia. Okay, EV and PHEV is still a luxury in Malaysia. Why? Because there's no tax exception imposed by the government yet. Compared to Singapore, they have to do a tax exemption to drive the business. Okay, so this is like a chicken and egg things. Okay, so it will not be crowded, but this is where the destination charger is also take into place. You know, nowadays hotels start to offer, hotel shopping malls start to offer a charger. Okay, so and also hotels. Okay, if you see some hotels in Penang, Cameron Highlands, in JB, and in Perak, they will offer a EV charging to a car. Some will charge, some will provide it for free. So it will not be too crowded because it's less than 1 hour. So this is where we want to plan to install more charger, not at the petrol area, but at a certain location in the R&R area, whereby people with EV car, instead of going to a petrol station, they can go to a area that designated for them to charge the car. So for now, it's still at the petrol station. But in the future, this is where we and also an NGO try to push, whereby they have a certain area in the other area whereby they can charge by themselves. They will not interfere with the ICE car petrol fillings in the location. And then what I was okay, I want to ask about distribution box DB in the house. You know, 3-phase. Okay. Is it necessary to each DB except main distribution box to have main switch, or just RCCB is enough? Okay. in an ST installation requirement, you will need an MCB, you will need an RCCB. Okay, now you need an SPD. It's not a matter of if you have 3 panel, you can install 1 panel each. Okay, so um, so it is important that you need to install all 3 components in each of the panel. But SPD is common. You assess the risk. Maybe you need to install the main DB, and then the secondary and third DB you don't need to install an SPD. Why? Because let's say you say the question, you have a house with 3 phase about 3 dB. So this is where the ground floor is the main incomer. First floor is for the first floor power. Second floor is for the second floor protection. Okay, so normally people do this for separation. Okay, when there is a when there is a power failure, only first floor or second floor will trip, not the whole building. Okay, but you need to install each of these DB with MCB and RCB as a minimum requirement. Is it contradicting the MCB, but you haven't the so does using immobility in our country relevant? Okay, we need to adopt. Malaysia issue is we are very late to adopt. Okay, if you see like Indonesia, they're very fast. They are promoting EV. They even ask Tesla to build an EV factory. Build an EV car factory in their country. Okay, so renewable energy, solar power is easily commercialized, yes, but I would try to defer that because every year under KETA they will open a renewable energy quota to building, to residential, whereby this particular owner can bid, and also when they want, they can install in solar power at the building or at the residential itself. So I would say e-mobility is our country not 100% relevant yet, but we are moving into that. If we want to reduce the carbon emission by 2035 or 2045. All right. Basically, first is how about the system in the main switch compared to MCB and LCD as you explained this before? Main switch is the first device that supply goes to the after the TMB meter before going to MCB. Okay, it's the same thing. Okay, but for the main switch, you can install MCCB or MCB with an isolator or a fuse. Okay, and if the main switch is just to provide power to the additional panel, then you don't need to put RCD inside. Okay, for the main switch, there is a type that use the fuse to trip. Okay, fuse is not a normal thing. Fuse is been used for many years, even before I was not even born. Okay, the problem with fuse is that it's not easily maintained. It's not too easy to maintain. Take example, your fuse blown in the middle of the night and you don't have any extra. What will happen? You will have blackout for the whole night. With the MCB, it's easy to maintain, where you can turn it on and off directly after tripping occurs. So this is different between fuse and the MCB. Back in the day, I think I have using a few. Okay, good question for Nuranis. Okay, this is what I call hydrocell. Okay, this is what I call hydrocell fuel. Okay, whereby you convert oxygen or water to a power. Okay, reason is hydrocell is very expensive, and then why people doesn't prefer to use hydrogen cell fuels is the efficiency. Okay, EV car, when you full charge the car, you will get about 90% and above efficiency on the power. But using hydrocell fuel, what will happen? When you it will reduce the efficiency up to 70%. So this is where people come into play. They want to improve the technology first to ensure that the efficiency is increased before it can be promoted. This is the reason. All right. From Nadira, we're charging. Do we have to always full charge the vehicle? Okay, this is based on the preference of the owner itself. Okay, it is best to full charge the car. Reason is to maintain the battery life. Okay, when you have the battery life, you can prolong the battery life when you full charge the car. Okay, based on the discussion with me with the EV car owner, minimum must be 80%. Okay, but it depends on the user itself. Okay, some people doesn't care, they just charge half of it, let's go, because of the distance itself. Okay, tadi saya ada baca ada yang cuba recreate tapi kenapa tak juga secara luas. As I mentioned, Noranis, the efficiency is 70 is very less, so people doesn't want to create it anymore, they go for EV. Unless there's a new technology, I believe some of the car manufacturer or some of the NGO are trying to recreate back the hydrogen cell fuels. Yes, but we won't see it in the near future. Even you can see like Sarawak, if I'm not mistaken, SCSB, they are venturing to with Petronas on the hydrogen cell fuel, but I won't dare to say it will be happen in within 5 years because the technology itself is still back compared to the EV. Okay. And then from Hilmi, wireless MCB. What do you mean by wireless MCB?
Sebab sekarang saya ada baca macam dia sendiri turn on or turn off the MCB. Ada dari company Latif pun ada juga saya baca ni daripada sendiri elektrik.
Okay. Wireless. It's not a wireless MCB. Okay. It's a device whereby you can remotely turn on an MCB when there's a trip. Okay. This is what we call a remote tripping. And now what I call wireless MCB, I think you are referring to a power tech, which is a device that you put on the top of MCB. Benda ni letak ke atas MCB, whereby you can monitor on and off or the power consumption. So this is part of the new technology that Schneider have, whereby people can just tap in whatever breaker they want, whatever RCCB they want, and then they can just monitor the power. And they possibly can turn on, but still they need to use an auxiliary installed to the breaker to turn on and off. But it can be wirelessly because you can connect it to your LAN cable, your RS-45, or you can use an apps directly. When you are in a remote location, you can turn on and off. Okay?
Thank you.
So,
Assalamualaikum sir.
yeah.
Saya ada satu soalan. Saya nak tanya pasal distribution board untuk rumah yang pakai 3-phase supply yang ada 3 DB board. So saya nak tahu setiap DB board tu memang kita perlu letak ke 3 phase ataupun boleh je satu DB board tu untuk satu phase.
Maksudnya apa? Ada 3 board, ada 3 DB board.
Board dan setiap satu board tu memang kita kena letak red, yellow, blue ke ataupun satu DB board tu red je, lepas tu DB board yang kedua yellow je. Boleh macam tu?
Okay, selalunya kalau orang guna lebih daripada satu DB board, diorang nak separate red, yellow, blue. Okay. So normally untuk ground floor dia letak red, second floor letak yellow, third floor letak blue. Why? Because let's say contoh daripada TMB, red phase saja yang blackout ataupun blue phase saja yang blackout. So the other two phase still function without any issue. So this is where I call discrimination come into play. Saya tak touching benda ni dalam saya punya slide. Discrimination maknanya kita nak avoid unintentional tripping. So when you do this, it's allowed, and actually people are practicing this nowadays, especially when they have 3 phase. Tapi dia orang boleh juga guna kalau dia nak masuk 3 phase terus masuk je dekat incoming and then they split by themselves. But normally people akan split by phase in each of the floor.
Oh, okay. Terima kasih Encik.
Any more question? Or you guys want to ask about my experience, what I have been exposed to? Encik, wireless MCB tu pakai radio signal ke? Radio frequency signal. Yes, correct. Radio frequency signal. So take note, if you're using any radio frequency signal, you need to get approval from MCMC. Okay. Any frequency that you're using, even your phone, you can check there is a MCMC approval. So they use a radio signal. There is a frequency that is specifically used to control the breaker. Any more question? Anything you want to ask me about my?
Sir.
Yes.
So, saya nak tanya pasal macam pengalaman saya lah. Macam lepas degree, lepas cik ambil degree kan. So, dan macam mana saya teruskan kehidupan tu sebagai apa yang saya jadi sekarang tu.
Okay.
Apa yang saya ambil apa semua.
Okay. Mungkin saya boleh cerita background saya lebih sikit lah. Lepas saya graduate daripada saya punya degree in power engineering, saya start kerja with a company called Hager. I sure you orang semua tak pernah dengar. Okay. Hager is one of the French company located dekat Shah Alam. So there I started work as a technical engineer and also do some marketing, also do some sales. And after a few bags, this is where I learned a lot of technical with my sifu. Okay. Then after that, saya moved to Schneider. Actually, Schneider is my third job. Second job is just an interim. Third job I lose at Schneider. So this is where at Schneider I've been exposed to marketing and sales roles more, but I still covering on technical. Okay. So to be honest with you, it's quite challenging because if you're working in an international company, MNC company, the demand is really high. People akan tanya soalan dan minta you jawab dalam masa 5 minit. Tapi it's all on you how to manage your stress lah kat sana. Okay, because macam saya, my role now is I'm doing cluster. So I also handle Singapore, Malaysia and Brunei. So you can imagine a lot of salesperson, a lot of big boss, a lot of boss akan datang tanya a lot of question, a lot of funny question, minta macam-macam. So this is how you handle. So for me, stress is number one. How you handle your stress, how you handle the people. And years to years, when you start to working, you will see that your maturity will come into play. Okay, mungkin masa mula-mula you kerja, you agak panas baran sikit, agak tak sabar. Tapi the more you learn how to manage people, you will become more professional. Okay. Mungkin awak rasa saya cakap BM ni agak pelik bila cakap pasal kerja. Memang saya memang cakap English all the time bila saya di tempat kerja. All the time. Okay. Saya tak boleh berbahasa Chinese, Mandarin, Cantonese. Saya plan nak ambil sampai sekarang tak dapat, tak ada masa. Okay. And then 80% of colleagues saya adalah Chinese. And then we respect each other. Okay. So when you work, please put aside things that related that sensitivity, racial, agama, whatever. Be professional, and then one of the most important thing is you need to show that the company needs you, not you needs the company. Okay, it's a very tricky, but for me, along the line, you learn and show that you are a valuable asset to the company. Okay, you are the valuable asset. People nak you sebab your expertise, your knowledge. So that's why I say, don't work for money. If you work for money, then that's it. You will go, masuk pukul 8, balik pukul 4. Pukul 9 masuk, pukul 5 balik. And people will say, this guy tak boleh pakai. Okay, I'm saying this is the truth. Okay, industry working life is very kejam. Either people pinpoint you or you pinpoint people. But for me, I don't do that. I show my values to the company. So when they see me, okay, this guy have values. This guy is an important asset to the company. Okay, tell you the truth. Okay, in Schneider Electrics, you can count finger how many Malay people inside the company. You can count with finger, maybe 10, maybe 5, maybe 6. I forgot already the number. But I show the value. Even my boss is Chinese, and he trusts me. I can give advice. I can give him my opinion. He can listen to me. My big boss is a Korean now. Last time he's a French guy. Now he's a Korean. Okay. My finance is a Korean guy. It is a Korean lady. My CFO. Okay. So working with this kind of environment give you a lot of exposure. Give you a lot of exposure, and the most important is need to manage. And the most important, another important is make sure your value is recognized in the company. Then you can move forward. Not just you have PhD, you have master, then you show value. No, people will see how you work, how professional you are. Then they will value yourself from that portion. Okay. Any more question? So if you Google, you can see my face in the newspaper, in a YouTube video. So this is the thing that I've been doing for the past few years, give awareness, give knowledge to people. All right. I see some question there. So berkaitan mesej tanya dengan bekerja dengan local company. To be honest, I'm a workaholic. Okay. So normally what I did is I ensure saya bekerja ikut masa dan saya deliver. Local company normally is quite relaxed lah, I can say. Quite relaxed. Compared to MNC, because saya deal dengan European, saya deal dengan orang Singapore, so the demand is high. So as I mentioned just sebelum ni, stress management is very important, dan jangan lupa your professionality and how you manage the thing. Okay. In the automobile, nasi dia strategy sebab saya cuba to reduce use of petrol. For me, turbo is just a power. Okay. Sadly, as I mentioned to you, if you use EV, okay, you can Google any of the video in the YouTube. You can check Tesla versus which car, or this car, EV car versus this car. You can see the EV car is more powerful than petrol or even the turbo car. Why? Because an ICE car, electric petrol car, that we have losses. Means from the engine to the drivetrain to the axle to the tire. But for BEV car, electric vehicles, it directly simple macam kita anda tahu Tamiya kan? Pernah dengar Tamiya kan? Mesin masuk bateri terus jalan engine kat belakang. It's the same principle. It's the same principle. So the losses is very less and it's super fast. And if you happen to meet one of the BEV owner, cuba tanya dia orang maintenance macam mana. Their maintenance is super less. Some of them tak pernah buat maintenance for 3 years. They don't need to do maintenance sebab dia tak ada tukar punya engine. Even brake pad, saya tanya brake pad, kalau macam kita normal kereta setahun sekali, 2 tahun sekali, 3 tahun sekali, kereta dia 5 tahun, brake pad tebal lagi. If you don't believe me, go to the Facebook group, they call it My Evoque, My Electric Vehicle Community. Join there, you can see they will share a lot of info about EV car. Okay, then you will learn a lot, but they will complain a lot. So take a positive thing, take out the negative things. Okay. Reconnection lebih jemaah related benda circuit sebab saya tak pernah dengar lah soalan ni, ring connection dia berjimatkan electric motor radial. It's only based on connection sajalah. Okay. So bagi pendapat saya tak ada kena-mengena dengan electricity, maksud saya electricity, penjimatan elektrik, cuma in term of radial circuit it's more safe lah compared to ring. And then the continuity of service, because for radial circuit, contoh lah macam if you recall my slides, right, connected loop. So kalau satu rosak, kalau kontraktor salah buat, semua sistem akan off, tak ada power. So radial is 1-to-1. But people don't go for radial because it's costly. Dia tak boleh pull kabel dari panel pergi satu, dari panel pergi satu. Saya berani jamin kontraktor takkan buat punya. Dia takkan buat. They go for connect ring circuit sebab senang nak buat installation. Cuma kalau ada specific load, yes, they need to pull one to one. Contoh macam water heater ataupun untuk aircon. So that one type of load memang kena one on one. Untuk lighting socket biasa dia akan buat ring. Memang standard installation Malaysia macam tu. So any more question?
Kalau dah tak ada, saya tutup sesi soal jawab. Ada lagi kan tak boleh tanya? Okay, saya rasa tak ada dah. Majlis mengucapkan ribuan terima kasih kepada Encik Mazliazhar atas ucapan dan perkongsian beliau sebentar tadi. Banyak perkara yang telah kita pelajari dari perkongsian beliau. Semoga segala perkongsian dapat dijadikan panduan dan pedoman untuk kita semua. Jadi sebelum kita akhirikan majlis ni, minta semua untuk kat kamera kita nak screenshot untuk bukti kita. Bukti dari tu. Okay. Boleh buka kamera sekejap sebentar.
Comeback Phoenix kita lama tak nampak.
Ada lagi ke yang boleh buka kamera?
Data.
Ya boleh buka kamera lagi.
Okay.
Okay.
Belum. Dah cukup
Belum. Ramai kita buka.
Najwa, Nur Anis, Juliana, Dr. Sim,
Fakrul Firdaus tu.
Hasrul.
Elia.
Ni banyak Cik Mazli kongsi experience, kongsi knowledge. Terima kasih banyak Cik Mazli.
Sama-sama.
Boleh jemput lagi ni.
Boleh. Tapi saya prefer face to face
Face to face Datang session lah.
Boleh, tak ada masalah. Nak travel kat ni. Boring lah duduk rumah. Saya dah work from home daripada bulan 2 ni.
Uish, duduk rumah monitor kat rumah.
Duduk rumah monitor kat rumah. Semua kerja dari rumah lagi banyak daripada office.
Betul cik. Saya work from home. Study kat rumah pun banyak kerja cik.
Dah nak setahun work from home.
Setahun dah. Ni dah extend lagi sampai 14 ni.
Okay. Yang lain, tak pula yang lain tu tak nak. Anis tak nak. Okay, boleh lah.
Okay, buka kamera. Ramai lagi dia baru nak siap-siap pakai tudung. Ada lagi nak buka? Okay, 1, 2, 3. 1, 2, 3.
Oh my god, dah semua.
Okay, terima kasih.
Oh dia off dia punya mikrofon, tak dengar.
Hilmi off microphone.
Helmi cakap seorang.
Okay, terima kasih saya ucapkan kepada Encik Mazli lagi sebab perkongsian hari ini, dan saya ucapkan terima kasih kepada pensyarah dan para pelajar sebab sudi join talk pada hari ini. Dan anda kata ada tersalah kata, tersilap bicara daripada saya minta maaf. Saya sudahi talk ini dengan wabillahi taufik wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam warahmatullahi wabarakatuh. Okay. Terima kasih banyak.
Okay.
kasih Cik Mazli.
Terima kasih, Cik.
Terima kasih Cik Mazli.
Terima kasih.
Student apa isi
Terima kasih, Cik.